It's not working. The live upload thing isn't working. All right, so perpendicular means they hit at 90 degrees. Not just that they hit, plenty of lines intersect, but these are special. They hit exactly 90. Here's the symbol for it, minus the little square I drew there. It's just kind of help you remember what it means. Now, remember, this is perpendicular. Perpendicular. Careful how you say that one. Parallel is what we learned about last week. And parallel means that they never touch, so the symbol for that is usually something like that. Okay, you can either do it straight up and down or slash-wise. Crouching Tiger, Hidden Dragon. You gonna get this thing for me or no? All right. I appreciate that. So perpendicular, again, two lines that meet at 90 degrees. Exactly. So we got line L, line M hitting at 90. Am I blowing anybody's mind? Hopefully not. All right, here we go. Let it begin. I know, right? So first off, if we eliminate this line right here, this middle line, we've got two parallel lines and a line that's cutting it. What do we call a line that's cutting two parallel lines? Transversal. They're intersecting, but specifically we call it transversal. So let's call that T for transversal. Now, technically this middle line is also transversal. It's cutting these two, right? So it's another transversal. What's nice about this, though, is that it hits this line. This line hits these two lines at 90 degrees. So they're perpendicular, right? So line AB is perpendicular to line DC. So how I'd write that is this. Line AB, perpendicular, that's a perpendicular symbol. Line DC. What other two lines are perpendicular? What other ones hit at 90? We got AB and DC. 90 right here. Where else do you see 90? AB and FE. So I'm going to write that. Line AB is also perpendicular to FE. Again, blowing anybody's mind so far? I'll try harder. No yawning in math class. All right. Let's talk about these angles. Mr. Eads, what do you suppose the measure of angle 1 is? How do you know? Why? It's perpendicular. Check it out. This angle and this angle are both on a line, right? We call that a linear pair. They have to add up to what? Okay, well, I know that one's 90, and I do, because they gave it to us. That's what that symbol means. What's 180 minus 90? 90, it's what's left over, right? So if one of these guys is 90, the other one must be as well. So angle 1 is also 90. Now, same dumb logic. Check it out. These two have to add up to what? 180, because they're on a line, right? So if I subtract 90, what's left over is 90. So this guy's 90 as well. Same dumb logic. Those both have to add up to 180, right? If that's 90, subtract 90, 90's left over. So all four are 90. Another way I could have done it, I could have said, look, this guy's 90, vertical angles, that guy's got to be 90, right? All checks out. I'm going to do that over here. This guy's 90, so what does that mean about this angle? It's got to be 90 by vertical angles, right? Scissor theorem. Now, we don't know what angle 4 and angle 3 are yet. We know what they add up to. What do angle 4 and angle 3 add up to? 90, right? They got to be, right? They make up the whole angle. That's angle addition postulate. The two little angles make up the whole thing. So this whole thing right here is 90. But 4 and 3 separately, I don't know. It could be 45, 45. Could be 30, 60. Could be 89 and 1, right? It could be anything. So we got to figure that out. Now, luckily, they give us an equation to describe both those angles. So I know not what angle 4 equals or what angle 3 equals, but I do know what they equal when you add them up. So if I add 3 and 4, I should get 180, right? Or I'm not 180, 90. So if I write that, measure of angle 4 plus measure of angle 3, I know equals 90 degrees. Why? Because they're perpendicular, right? We have a 90-degree angle there. Cool? So if I know 1 and 3 add up to 90, and I know this is what 4 and 3 are, don't I know that 3x plus 10 plus 2x plus 5 equals 90? Right? From earlier, right? That's what 4 and 3 are. Switch them out. Now we can solve for x. Ava, how many x's do I have here? 2 here, and how many here? 2 and 3 makes 5, so 5x is total. Isabel, 10 and 5. What's that going to be? 15. Again, they're on the same side, so you just do what it says, right? Add 3x and 2x. Add 10 and 5. Don't need to subtract, right? Now we can subtract. 90 minus 15, we're going to do it in our heads. I'm moving the 15 over by subtraction. Let's subtract 10 instead of 15. What's 90 minus 10? 80, right? But we got to subtract 5 more. What's 80 minus 5? 75, right? And I bet you feel pretty confident about that. Now, if I said 90 minus 15, you'd be like, maybe I'll get it right, right? But if you do 10 first and then 5 next, no big deal. Now we're going to divide by 5. Divide by 5. Alex, why do you say 14? Okay, so here's what he's saying. He has memorized that 5 times 12 is 60. Okay, so let's write that down. 5 done 12 times is 60. That's not big enough, right? How many more 5s do we need to add to 60 to get to 75? 3 more, right? So it should be 5 times 15. Get a 75. Makes sense to me, right? That gets us 60 according to him, and he's right. 3 more 5s will get us to 75, right? Because we're 15 short. So it should be 15. Now, another way you could have done it, maybe you don't know 5 times 12 is 60, but I bet you know what 5 times 10 is. It's 50, right? How many more 5s do I need to get to 75? 55, 60, 65, 70, 75. 5 more 5s, right? So 5 times 15 is 75. All right? So 15 times is how many times 5 goes into 75. So x is 15, which is all fine and dandy. But we want to know what angle 4 and angle 3 are. It says angle 4 over here is equal to 3x plus 10. And it says that angle 3 is equal to 2x plus 5. What do we find x to be? We found it to be 15. So I plug in 15 where x was. Always wrap it in parentheses. I'm a professional, you are not. Sometimes I choose not to wrap it, but I know what I'm doing. 3 times 15 is? What's 15 times 2? 30, right? 15, 50 makes 30. It's all right. Add one more 15 to that. 45. So that's 45. 45 plus 10 is 55. 15 times 2. 30. Add 5. That's what Tucker was saying. Now, remember, 4 and 3 are supposed to add up to what? 90. Do they? Let's do 50 and 30 together. What's that? 80. 2 5s left over. Is that 90? Oh, yeah. So that checks out. So angle 4 is 55. Let's label that on our diagram. And angle 3, 35. Mr. Eads, what do you notice?
6 is 55.
Why do you know 6 is 55? Says theorem. Vertical angles. Give me one reason why I know that angle 5 is 35. Scissor theorem. Why else would I know that's 35? Vertical is scissors. That's another way I could figure that out. What do I know about angle 5 and 6? They should add up to 90, right? Vertical angle says that this angle right here should be the same as this down here, right? So if that's 55, how much more do I need to get to 90? 35, right? All checks out. Let's talk about down here. Is line DC and line CH, are they perpendicular? We're not told they are, right? What does it mean to be perpendicular? Told you being in class, you guys all forgot it already. No, you didn't. Some of you know it. If you know it, say it. What does it mean to be perpendicular? They what? Plenty of lines intersect. We call those intersecting lines. What does it mean to be perpendicular intersecting lines? Yeah, so you hit at 90, right? Perfectly. Now, these don't appear to. We can't rule that out, right? Because looks can be deceiving. However, they seem to have told us when the ones were perpendicular, so it's probably not. And if they didn't tell us, we can't assume that, right? So we can't assume that these are all 90. And trust me, they're not going to be. So how do we figure these guys out? Corresponding angles? How so? Mm-hmm. He's right. Check it out. I'm going to ignore line AB. So I'm going to trace over it. If you need to do this on an exam, I would encourage you. So I'm going to keep the parallel line here and the parallel line here. I'm going to keep that transversal, but I'm not going to have the line that goes perpendicular to it. This marker's dying on me. Rest in peace, buddy. Buckets. So check this out. We've got angle 55 degrees here and a 35 here. That's not what I want. A 55 here. Right, that's what we said. 55 there, 55 there. Now, if you notice, that's top right. This guy's top right. So it must be 55 here as well. Same thing down here. Corresponding angles. Bottom left, right? So these guys are 55s. What do I know about 7 and 9? How can I figure them out? Yep. All of this is going to add up to 180, right? So what's 180 minus 55? Easier question. What's 180 minus 50? 130. We got to subtract 5 more. 125. Vertical angles, right? How you like them apples? Can be, if you see it. We've talked about this before, though, right? Remember this, Mr. Eads? How easy this was? Maybe 5 seconds to figure it out. And you got it wrong. Not because you don't know what triangles are. Not because you don't know how to count. Because you just didn't see it. Mr. Eads sees it. And if you don't see it, come see me. I'll help you out. Okay? It takes time. We do. Here it is.
Shoot, indeed. You do mine.
Here we go. See you tomorrow.